Hi classmates, my name is Alfredo Volares and I'm going to talk about a heatsink in which automatically cools itself. My team is basically made of Arsenal Laguna, Facea Hunter and Josh Contreras. This is an engineering project for Jamie Turner. And to continue, we have a problem, right? So when servers are rolled out to final production, one of the major problems is that server encounter is that components that are inside of the server must be thermally tested to see if they can be supported, especially for solid state drive and processors. Servers, mechanical hardware must be able to function at the range of ambient temperatures. By providing thermal tests provides the necessary data to determine whether or not components will be able to function inside of the server chassis at the highest performance. Not only this class will help us to deliver a solution, but it will also teach us techniques for modeling mechanical systems and understanding their responses to control inputs and disturbances by using engineering graphic programs such as Inventor and AutoCAD. As we go along the PowerPoint, we will find that we have different materials for heatsinks, especially for the two main ones that are aluminum heatsinks and copper heatsinks. The difference between both is that aluminum offers lightweight and good thermal conductivity, and copper heatsink is more expensive and heavy, but offers better conductivity. For example, Coffee Lake sockets, especially the i7-87K, basically they offer high temperatures, and we're dealing to cover a solution where we can actually lower those temperatures. To continue, my next team is going to talk more about this solutions that we have for this project.
Hello guys, my name is Arsenal Lehunov and I'll continue right now. Representation of system in a feedback control system as well as the techniques for determining what desired system performance specifications are achievable. Practical important when the system is under control with the desired heatsink that can overcome the temperature of the high performance PC, of course. We have three different heatsink types. Metal heatsink, choose a design that maximizes the surface area and the file with what you are trying to cool. This also needs to be kept clean. Fill it up with the dust and it will no longer work. Liquid cooling can cause temperature to go as low as 24 degrees of Celsius, but with a greater risk of damaging the computer components of the inside because of the liquid, of course. Fan pulling air for a regular fan on any type can cause a moderate amount of controlling the temperature and will also have a least risk and will offer more durability for the computer itself and for the heatsink as well. To continue, we can move on with our next teammate member, Isaiah Hunter. Thank you so much.
Hi guys, and I'm going to explain the two different types that we came in contact with that we were going to use. We had our sleeve bearings, which had a shorter life, they were quiet, more evaporation, and less expensive, while on the other hand we had our ball bearings, which was a longer life, quieter at high speed, less evaporation, but more expensive. The design that we created offers a mix of both designs and where it can last longer in life. We would be quieter at high speeds, and it will offer more evaporation for better airflow and cooling performance. The focus of this project is to create a heat sink with enough work, energy, and power for better performance inside of a PC. One of our main objectives was a system that easily sinks the heat of the server during the cooling of the processor. I realized I had to make use of the polarity of server modules. The system needed to include three cooling subsystems. That is the first cooling subsystems for circulating and first cooling medium through the first cooling system, which are the 7 long, tall dash. The second cooling should include a second polarity of conduits for circulating a second cooling medium. Below is the prototype that I implemented to the unit to test airflow. This will conclude our presentation, guys. For the project we're working on is still under development. So I just want to tell you guys thank you, and we had a great time doing all this.